we actually start with NXOS,
Mhm.
and the major topics here are, so say for example today, we will proceed with multicast in the very beginning. But for the other batches, I usually start with the Nexus hardware. Today we have a different approach, but we do the hardware first. Then we eventually go to the routing and switching. We talk about the multicast because it's very important for the VXLAN. Then in VXLAN, we talk about the multicast based VXLAN, that is the flood and learn, and we do the BGP VPN and also VXLAN with VPC. So which means some point here we will also cover the VPC, then its integration with the VXLAN and the multicast PIM, IGMP, and how those all things work. The reason why we are doing this with the Nexus knowledge is the Nexus hardware is exactly the same hardware which is being used in the ACI. It's the Nexus 9 case basically. Yeah. So that is one important thing why we are looking at the Nexus hardware. And while looking at the protocols, the ACI is nothing but a VXLAN fabric. So that's why we want our utmost knowledge on the VXLAN fabric. To me, ACI is I can say it's a VXLAN fabric plus the DCNM. That's how it used to be. Now instead of managing the VXLAN fabric with DCNM templates, we are making use of the ACI operating system. So that's what, in my opinion, ACI is an enhanced version of the VXLAN managed by the DCNM. So eventually we will drop down into the ACI and we'll learn about the different constructs we have there, how it works, how the packet forwarding, endpoint learning, why ACI is different, what it makes easy for us, the benefits. And through this course, I've also added some content from the advanced ACI operating system course. So if you look at the Cisco point of view, they have a course called DCACI. So in the DCACI, they talk about many things. Some things are reserved for the DCACI, such as a multi-pod scenario, a multi-site scenario, and we have the service graph. Now, previously, both service graph and the PBR both used to be in the ACI curriculum, but Cisco has now changed it that the PBR policy-based redirect is only a part of the ACI advanced. So we will include all those topics in our discussion here. So this is what we are looking at in the upcoming days. So of course, like you asked, we will have a complete knowledge of the underlay, our Nexus hardware and the various protocols associated in order to effectively understand the ACI working. So that's what our motive is. Okay, let me go ahead and share this multicast. Now, to give you an introduction on the multicast and what we will be discussing is, now as you all know, multicast is a CCIE syllabus from the Cisco perspective. First, we will look at the IGMP, its various versions and how it works. Then we will eventually look at the PIM, protocol independent multicast. And we will see how PIM is reliant on the RP, round viewpoint. How there are various messages associated with IGMP, with the PIM. We see it in working. We also have labs. We have lab for IGMP. We have lab for PIM. We also have lab for the RPs, because RPs, they could be statically configured. But that doesn't scale well. We want a dynamic method to configure the RP. So we will proceed for the dynamic methods. We have Cisco proprietary dynamic methods, and we have the open standard. So those configurations of the RP and what they do. So this is what we'll be discussing with the multicast. Now, why would we want to explore on this multicast is mainly because of these two reasons, like I mentioned earlier. In any VXLAN fabric, okay, you may have a control plane. If you don't have a control plane, okay, let's say you have no control plane, then in that case, you learn the endpoints by making use of the flood and learn, which is totally dependent on the multicast. Now that is one category. why we should learn about the VXLAN. And number two, the multicast. Okay, when you look at the multicast, it's PIM bidirectional that works on the VXLAN fabric mostly. So we need our understanding on how the bump traffic. Bump traffic is nothing but the broadcast, unknown unicast, and multicast traffic. How the bump traffic is going to be handled via the multicast backbone. So this is one primary reason why we want to explore that multicast. And number two, in ACI, we will talk about multi-port scenario. In a multi-port scenario, it is mandatory or must that you have a multicast support. Again, the multicast employed there is PIM bidirectional. So how that works, in the multi-port scenario. So to understand that, we because it is mandatory, like I mentioned, it is must that you have the multicast support for a multi-pod design in the ACI. So these are two reasons why we explore the multicast. Okay. All right. So this is what we are starting with now. Now Cisco has multiple variety of switches. You know that we have the Catalyst, we have the Nexus. Now this Nexus comes in multiple families, product lines. We have the 2Ks, we have the 3K, we have the 5Ks, you have the 7K, and you have the 9K as well. The 2Ks, as you know, is called as the FEX, Fabric Extender. Now the Fabric Extender is actually not a switch because it doesn't have the switching intelligence. All it acts is like a port extender. So the fabric extender is primarily used for the purpose of port extension. That's it, like an external line card. That's it. But the way it works, the intelligence behind it is actually sitting in the parent. The parent usually used to be the 5K. Now 5K is end of life. So the parent controls the switching intelligence behind the 2K. So all the configurations for the 2K that is visible on the parent, and you can configure it from the parent. As I mentioned, there is no switching. The CAM intelligence is not also present on the 2K. Then how does the movement of traffic is facilitated by the parent? So let's imagine this is the 5K. This is your fax, which means it's the 2K. And you have your servers here. Now let's say if traffic from server A has to move to server B, then the FEX cannot switch that locally because it does not have the switching intelligence. Therefore, the traffic will go to the parent and then it gets switched here. For that reason, the FEX is not usually recommended. If not for the port extension and the lesser cost, it is not usually recommended for the east-west traffic in the data centers. The FEX is usually accommodated for the north-south traffic because this one is very important. We will also see how the ACI fabric is accommodated, why we are now going for the 2-tier, not the 3-tier anymore. So that's because we have to accommodate the east-west traffic. So we know some basic idea about the FEX. The FEX is a fabric extender. The fabric extender is nothing but the Nexus 2K family model, which has no switching intelligence, but it can depend upon the parent switch where the configuration is present in order to do the switching between the corresponding end host. Yes. For this, it makes use of something called VN tag. We will talk about this. That the guide is also having this information. Like I mentioned, the 5K is end of life, and that is also one major reason why people are moving towards the 7K and the 9K. The 3K is the Nexus switches. It also supports many features like because all these are based upon the Nexus operating system. Like how you have the iOS, here you have the Nexus operating system. Now this operating system is so cool because it is not based on C, like how the iOS used to be. Now this provides multiple support, for the partitioning of the services and multi-threading, parallel processing. The box, because of its support from the NXOS, is now more enhanced, and it can perform the parallel processing, multi-threading, and there is one feature called, it doesn't have to wait to finish a particular sequence of command. It can simultaneously perform the sequences of commands. So the why the operating system is better, because it's based upon the Linux and it has inherent support for Python. So actually in the NXOS CLI, you can execute Python commands. So there is a line by line Python interpreter coming together with the NXOS. You can also run the Python scripts on the NXOS. At this point, I do not have any labs for the Python scripts, but however, I'm trying to add one. Probably if I have time by this weekend, I shall include one lab on the Python script, which can be run on the native NXOS. So all these boxes, the 3Ks, 5Ks, 7Ks, 9Ks, all these have the NXOS. Now, what is the difference between them? Is their capacity. Now, the 7K and the 9Ks, these are the higher end boxes. Okay, these are the higher end. The 7K is usually modular chassis. You would have seen it. That is the modular chassis type. The 7K is the only variety which supports VDC, virtual device context. We already know what is a VLAN. A VLAN is one switch but has multiple interfaces. Some of the interfaces have been put into a certain VLAN so as to distinguish the broadcast domain. That's what the VLAN is. We know what the VRF is. A VRF is a virtual routing and forwarding instance, which is created out of a particular route. So basically multiple ribs. That's what the VRF is. And what this VDC is? A VDC is a virtual device context, which is, let's say you have one switch here. That entire box is being split into 3 or 4 different, now usually it comes in varieties, 4+1 or 8+1. So there is one admin VDC plus many other VDCs. So which means you can have now 5 switches in the same place. Now physically it looks like just one box, but logically it is 5 independent switches. Which means inside one switch you can have 4,000 VRFs. Okay. So you have 4 switches, which means you can now accommodate up to 16,000 VRFs in each of those. I must say 4,000 VRF per VDC. That's how it is. Now, why do you want this? Why would you want to prefer this? The footprint, as you see, is less, but however, you now have more independent switches on the same place of the same physical switch. Now, that could be because of the design or administrative segregation, fault isolation. There are multiple benefits of that. We will look at this feature a little later, but this feature is only supported by the Nexus 7K. That's what we want to mean. The 5K is now gone. There is also something called the 6K. Usually we do not say that as a 6K, but this is a special product. It's called as a fabric interconnect. Cisco not only provides you the switches, but also the servers. Yes. So we have the fabric interconnect. The fabric interconnect is a switch based upon the NXOS, which is used in the compute environment. It is used in the compute environment. This is one specific different unique box. So that's why I'm talking about it here, because it has the switching capacity of the NexOS, but it is usually not classified as a Nexus switch. In Cisco, there are different types of servers. We have C series rack servers, we have storage servers, and then we have the B series blade servers. Okay, we have the B series blade servers. If you want to configure the C series rack server, every Cisco server has a management interface portal called the SIMC, Cisco Integrated Management Controller, through which you can log in and you can configure the rack server. Suppose if it is Cisco had a model called Hyperflex servers, HX nodes. Now this has been provided to Nutanix. Cisco no more has this Hyperflex with it anymore. I think this happened like 4-5 months ago. Cisco also has this Hyperflex, and it has a HXDP platform in order to configure the Hyperflex node. But for the blade server, it looks like this. A chassis. You have the blades all embedded into the chassis. I'll talk about one model here. It's P5108. If you want to configure any of the blades here, you cannot do it directly. For the rack, you may console into it, you can configure it. For the Hyperflex, yes, you can do that. But for the B series blade servers, you cannot do that. You cannot directly configure them. Then how do you configure them? This B5108 is actually managed by the Fabric Interconnect, FI. So you log in into the Fabric Interconnect, and from the Fabric Interconnect, you configure these servers here. That is called by a term called service profile. So the configuration of the blade servers plus the switching for the blade servers is all managed by the Fabric Interconnect. The Fabric Interconnect is both the Nexus operating system for the switching plus the UCS manager. It is called as UCS manager in order to manage the blades. So this is one variety. It's usually called as the Nexus 6K family because it is nothing but the 5K plus the UCS capacity. So that is one variety. Now comes the giant, the most important switch variety of the Nexus. That's the Nexus 9K series. The Nexus 9K series comes in two varieties. Okay. The first variety is called as a 9500 series, which is a chassis type. And then there is another variety called a 9300 series, which is a fixed port type. Right now, we're only discussing about the theories, but we do have some appropriate, slides talking about how they look like and what is the various components present in each of these switches. Yes, and by the end of this session, I would have already shared the next guide with you. We shall go through it. Okay. Because we are only doing the, a quick intro on the hardware now. So we have the 9500 series and the 9300 series. Like I mentioned, the 9500 is a chassis type. You have three important models here. The 9504, 9508, and 9516. What this means is, in fact, Cisco has a naming convention. Okay, if you look at this 9504, what it means is 9 stands for the family, 5 stands for the series, and 04 stands for the number of line cards it has. So 04 means 4 line cards could be supported, 08, 8 line cards, and 16 line cards. That is the major difference here. Now, since it is a chassis, it will also have the power supply units, fans. Then what is present? You have the line card on the front, you have the power supply unit, and then you have the fans, you have the fabric controller and the system controller. You do have the soups. There is 2 soups. For the purpose of redundancy, you always get to have the 2 supervisors present in the modular chassis. Yes. You have the fabric controller and the system controller. Now the soup is actually the brain. The soup is the brain that manages all the, the control plane. Everything is managed by the soup. There is a clear-cut picture of how the line cards talk to each other and how the line cards talk to the supervisor. And because the work of the fabric controller and the system controller is that they facilitate the talking of the line cards to the supervisor. If you look at the chassis arrangement, this is, let's say, the chassis. I said this is 9508. You will have the line cards horizontally. Yeah, you have the line cards horizontally. And you will have the fabric controller sitting vertically behind this. So which means the fabric controller provides connectivity between the line cards. So if how the line cards talk to each other, then that's happening through the fabric controller. Because the fabric controller is now providing the mid plane in the chassis for the line cards to talk to each other. That's the hardware trace. In fact, if you look at the chassis, unlike the 7K series, the 9K, the box is simply empty. Cisco proudly says that this is because we want good airflow. And the fabric controller and the line cards, they just are placed orthogonally to each other at 90 degrees. You insert the line cards horizontally, you insert the fabric controller vertically. Now you can support up to 6 fabric controllers. That is the max number. But it is not always you can want to have 6 fabric controllers. It depends on the line cards capacity actually. In some cases, if you have 6 fabric controllers, only 4 will be used and 2 will be in the redundancy. 4 plus 2, that's how it is. So depending upon the line cards, the fabric controller, number of fabric controllers required is also determined. That's how you reach the full scalability. Also, the compatibility between the line card and the fabric controller is very important. And one more thing to notice here is that not all the line cards support the ACI operating system. Okay. So care should be taken to notice which line card support the ACI operating system, which line card support the, basically everything supports the NXOS. Now, apart from that, the fabric controller should also be capable to accommodate the line cards. That should be taken care of. Then apart from that, you already have the supervisors. If the line cards need to talk to the supervisor, then they come via the fabric controller. There is the 2 different channels. We'll talk about it. There is the out of band channel, which is present in it's a chipset, which is present on the system controller. Now through that, the fabric controller can talk to the supervisor. There is also one more way in which the fabric controller itself can talk to the supervisor. One is reserved for the control plane, and I think the EVO-BC is reserved for the the physical maintenance, because the system controller does the physical maintenance of manages the fan and the power supply of the chassis. We will come back to it eventually. So we have the 9500, which is primarily the modular chassis. So the takeaway here is you have 9500, and the 9500 is modular chassis. So it has a lot of components now, many line cards, supervisors, fabric controller, and system controller, each doing its own function. Then we have the 9300, which is the fixed port switches. The fixed port switches, so let's take one model for example, 9332C. One important thing to notice here is the ASIC which is present on the line cards here. In this particular model, the 9K, the 9300 or the 9500, we have Cisco's cloud scale ASIC. If you look at the Nexus 3 case, the ASIC they have is mostly from the Broadcom, Tomahawk, and the different line cards they have is from the Broadcom. Now, even here in the fabric controller, the ASIC that you have is from the Broadcom. Depending upon what chassis model it is, the fabric controller will accommodate different numbers of the ASIC. So the ASIC could be just simply 1 or 2 or 4, depending upon whether the fabric controller is sitting in 9504 or 08 or 16. All those ASICs are Broadcom ASIC. But for the line card, you have the Cisco's cloud scale ASIC. It is no more a vendor ASIC. It is Cisco's own ASIC, cloud scale ASIC. Now, what is the difference here? If you look at the papers, the cloud scale ASIC holds more transistors because the size of the transistor is 14 nanometer as opposed to the Broadcom ASIC where the size of the transistor is 28 nanometer. So which means if you can have 100 transistors in a Broadcom ASIC, now here in this case you can double the size, you can have 200 nanometers, because of which the switching capacity, the cache, the table size and everything has been increased, which finally accounts to the scalability as well. So this cloud scale ASIC is a trademark. It's a significant feature of the Nexus 9K variety. So far we have been talking about the Nexus 9K and especially the 9500 series, which is a modular chassis type. The next variety we have here is the Nexus 9300, which is a fixed port. So let us take two models, for example. 9332C is another example. The naming convention is also clearly mentioned in the guide. So like I mentioned, this one stands for the family, this one stands for the series, and this, in the case of the modular chassis, it was a number of line cards. So look at the 7708 from the 7 series, 7K series, yeah, 8 line cards. Same, the 9508, 8 line cards, 9516, 16 line cards. But for the fixed port switches, this number is to represent the number of interfaces, physical interfaces. So how many physical ports? So in this model, the 9332C, it means you have 32 interfaces. That's it. 32 interfaces. The C represents that each of those interfaces is capable of 100 gig. That's it. And what is this 108? Does it mean the switch has 108 ports? No. There is also the naming convention, which refers to the number of ports in terms of its bandwidth capacity. So here it means there are 108 ports of 10 gig capacity each, which means the total bandwidth capacity is 1080. So this you can split like 600 plus 440, 480 something. So 600 maybe like 600 ports, sorry, 6 ports each capable of 100 gig, and here 480 probably 12 ports, 12 ports each capable of, what is it, 40 gig? 40 gig. So likewise, they accumulate, they get the cumulative value of the total bandwidth of the switch, and then that total bandwidth is represented in terms of 10 gig port, logical 10 gig port each. So that is one model. So if it is YC, Y is actually 25 gig, C is 100 gig. And then we have this models, 9316D. These are giants. Each port is capable of 400 gig. When D is represented in the naming convention, that means each and every port is capable of handling the 400 gig. We have same 9332D, 9364D. There are many switches. Even I think we have the 93. I don't know if it is 96 ports. 9364 is definitely present. So all those ports capable of handling 400 gig, they are used. So why do we focus on this bandwidth? And what do we want to, or where do we want to use this 9500 series and the 9300 series? You see, the primary use of the 9500 is majorly that it will go into the spine or the backbone. If in ACI, it can be used as the spine. And the 9300 series, some models, such as the ones capable of handling 400K, they will go into the ACI as a spine. The other nodes are used as leaves. We'll come to individual, model capacity and its data sheet later. For now, this is the introduction I want to discuss about the Nexus hardware. There are many things pending, how the supervisor is elected and how the Nexus operating system works in detail. What is the various, the components, how the rib gets, the fib gets moved to the module, and the working of individual component of the hardware itself. Okay. So that is it, pretty much the introduction, an idea, general idea about the Nexus hardware. The takeaway is that what are the various varieties of the Nexus we have, out of which what are real switches and what are the port extenders, and the working of the port extender is a pending. We'll do the VN tagging later. Then talking about the 3Ks, 5Ks, 6Ks, 7Ks, and the 9Ks, we focused heavily on the 9Ks. We understood, we have a general idea now how the chassis would be like and how a normal fixed port switch will be like. The difference is that you get the power to granularly select the line card and you can scale it as per the requirement when you go for a chassis. We also looked at the fabric interconnect, which is a special guy among the Nexus variety, which is being used on the server side in order to, because it's very effective, even for the CCIe DC, you have this topic, the UCS and its what its capacity leveraged by the FI, the fabric interconnect, which can integrate both the LAN and the SAN traffic. Like the Nexus 5K, it can handle the FCOE. So that's how it can do the LAN and the SAN traffic together. So we saw that. Yes. So that's pretty much about the Nexus hardware.